Well, welcome back, and yes, we are still on our journey talking about water. So we've talked about water's high latent heat capacity, high latent heat, its high heat capacity, looked at calculations to do with these, and now we're going to look at the fact that we said that water is a good solvent. So we're going to look at exactly what we mean about that and how water acts as a solvent for a number of different compounds and types of compounds. So in order for us to fully understand this, we need to get some vocabulary down and understand what we mean by a solution. Okay, so we know that water is a highly polar liquid, okay, because of its presence of permanent dipoles or polar bonds, and that it can form hydrogen bonds with solutions. This means that it allows water to dissolve a large number of substances to form solutions. Okay, so where we have a solute that is dissolved into a solvent where we are unable to see the particles. Okay, so when we talk about a solution. So when we define a solution, it's defined according to a number of characteristics. That is that they're homogeneous, which means that they're the same throughout, that every part of the solution is the same as any other part. That the dissolved particles are too small to see, so we can't see the evidence of a precipitate, we can't see any silt or fine solid particles or anything like that. So there's nothing suspended in it, that the particles are too small to see. That the solutions are transparent to visible light, i.e. light will pass through them unless they're highly coloured. Okay, so we can think about things in terms of like Coca-Cola in this case. It is a solution, but it can be quite difficult to see through. So it can be highly coloured, okay, in terms of it still being a solution. Okay, and then the proportion of the dissolved solute can vary from one solution to another, which is a concentration, which is a measure of how much solute is dissolved into the solvent. So like weak cordial versus strong cordial when we're talking about this. So these are each of the things that we define a solution by. Okay, so solutions can vary in concentration, they can vary in transparency and depth of color. Okay, so they can be clear and colorless, or they can have a color as well. They can't, however, have particles visible, and they must be homogeneous in order to be a solution. So the key vocabulary that we need to look at when we're talking about this is, of course, solubility. In order for us to make a solution, the solute must be soluble in the solvent. So the solubility is the measure of the maximum amount of solute that can be dissolved in a given amount of solvent at a particular temperature. And we will look at this in more detail later on, okay? But its units are generally the mass of solute per 100 grams of solvent when we look at it in chemistry. Solvent is, of course, the liquid in which the solute is dissolved. Water is not the only solvent. It is the most common one that we tend to look at, though. Okay? So a solution is a combination of a solute and a solvent. Okay, when we have the solute dissolved into the solvent, we form a solution. In terms of a homogeneous solution, of course, we said that homogeneous means that it is the same throughout, so the particles are evenly distributed throughout the solution. And then this one you may or may not have heard of before is miscible. So two liquids are miscible when they dissolve into each other, forming a homogeneous solution. Okay, so this would be, instead of having a solid solute and then a liquid solvent, okay, this is when you have two liquids that are then mixed into each other and go together. So ethanol and water would be miscible in each other. Ethanol is soluble in water. So when we are talking about two different liquids, we refer to them as being miscible. Or immiscible means not able to dissolve into each other, which is the case of water and oil. So when we talk about dissolving, there's three processes that must occur when a substance dissolves in a solvent. Okay, so the solute interparticle bonds are broken. So if it's an ionic solid, the ionic bonds are broken, separating the solute particles. Okay, so this could be ionic bonds, it could be intermolecular forces between a covalently bonded substance, okay, but these are the solute interparticle bonds that are broken. The solvent interparticle bonds, okay, so these are definitely going to be intermolecular forces, are broken, separating the solvent particles, and then new solute and solvent particle, solute and solvent attractions are formed, okay? In order for something to be soluble in another thing, it has to form strong bonds to the solute, okay? The solute needs to be able to disrupt the intermolecular forces between solvent particles in order to be able to dissolve. Okay, so if you take a solute and the solvent, we need to break intermolecular forces between the solvent and the solute particles in order to make new solvent-solute bonds, okay, or forces of attraction, because they're not chemical bonds, they are intermolecular forces. We're not forming covalent bonds or anything like this, okay? And it's very important to remember that dissolving and melting are very different processes. We melt something, we take it from a solid to a liquid by adding heat. When we dissolve something, that solid is going to aqueous. It is now floating around in solution with water, okay, but they are different things. So for a substance to be soluble in a solvent, okay, the solute-solvent interactions must be stronger than the solute-solute or solute-solvent interactions, okay? So we need to be able to make new interactions between the solute and the solvent, okay, in order to form nice, stable solutions that won't separate out because we have particles that are visible, okay? So this is the dissolving of sodium chloride. And over time, what we end up with is more and more ions being surrounded in what we call a solvation sphere of water. Okay, so this is the water surrounding our ions. The general rule is that like dissolves like, so a polar solvent will be able to dissolve polar solutes, okay, and a non-polar solvent will be able to dissolve non-polar substances. Okay, so this is on solubility in terms of identifying why the solvent properties of water are so important. Okay, so I'm going to end this video here, do this textbook reading, and then answer the textbook questions. And I'll see you in class.